When the pressure is applied across the electrodes, current starts flowing in the tube as a stream of particles from cathode to anode. These were called as cathode rays or cathode ray particles. Here whatever the electrons are propagating, that was produced by heating in a tungsten filament. The positively charged particles depends upon the nature of gas present in the cathode ray tube. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today I shall start up the new chapter, that is Unit 2. The name is Structure of Atom. First we will see the examination corner of this unit. There is a 20 periods need to complete this chapter, and the overall marks weightage, whichever you required, is the marks allotment is 9 marks. And the content, what are the contents we are explaining today is introduction, discovery of electron, charge to mass ratio of electron, discovery of protons, the characteristics of the positively charged particles, discovery of neutrons, properties of fundamental particles. These are the contents I shall explain you in this session. First we will see how the atom came into existence and the introduction part of the chapter. The Indian and Greek philosophers at the time of 400 BC, they discovered the existence of atom, and they stated that atoms are the fundamental building blocks of any matter. At that time, John Dalton, he is the scientist. What he told means, he proposed the Dalton's atomic theory, in which he stated that atom is the ultimate particle of matter, and that atom, he took the word or the term from the Latin word, that is atomio, which means indivisible or uncuttable. Okay, that's what he told. The word atom has been derived from the Greek word atomio, which means uncuttable or non-divisible. The atomic theory was first proposed by John Dalton. His theory, named as Dalton's atomic theory, regarded as the atom is the ultimate particle of matter. The subatomic particles are electrons, protons and neutrons. But what John Dalton told means, neither be created nor be destroyed. But when Michael has proved the experiment that the first Michael Faraday discovered the subatomic particles by producing the electric current in the atom, and it showed the discovery of electrons, protons and neutrons. Okay, and first we will see the discovery of electrons. The discovery of electron was first done by J.J. Thomson, and electrical discharge in partially evacuated tubes called cathode ray discharge tube. What he did means, J.J. Thomson, who is a chemist, he took a cathode ray discharge tube. It was partially evacuated, in which gas has been given and two metal pieces were there. What are those metal pieces? Were called electrodes, and one metal piece or one electrode will call it as anode, another metal piece or electrode will call it as cathode. Okay, a cathode ray tube made up of glass containing of two pieces of metal called electrodes. The electrical discharge is observed at a very low pressure and high voltage. In the electrical discharge tube, it was having a low pressure and high voltage. When the pressure is applied across the electrodes, current starts flowing in the tube as a stream of particles from cathode to anode. These were called as cathode rays or cathode ray particles. Okay, first he set up the all discharge ray tube, and when the current or when the pressure is applied in the discharge tube, what will happen? The stream of particles, the current will pass as a stream of particles from the cathode to anode. These stream of particles will call it as cathode ray particles. These are the experiment observations. Okay, but results are there still. This is the experimental setup. This is a overall discharge tube. Here cathode, here anode, and the pressure, see here 0.001 millimeter of pressure, very low pressure, and high voltage 10,000 volts. It is a high voltage. Okay, when the current is past, the invisible cathode rays, okay, the invisible cathode rays start moving in a straight line. The anode having a perforation, it will pass through the perforation and hit this material as a dark spot. Okay. What is this material means? This is a fluorescent material. Here they have used zinc sulfide, right? And here the cathode rays are completely invisible. When we will get to know it has been moved straight means by hitting of the fluorescent material. Okay. And what next J.J. Thomson did means he applied or he gave a that experimental setup in such a way he applied electric current. This is positive side and this is negative side. At that time again he passed the current. That at that time these particles were deflected towards the positive end of the electric current. And the same observations was shown when he applied a magnetic field also. Then he told that whatever these particles are present, it is completely negatively charged, and those negatively charged particles he named later as electrons. This is about the cathode ray discharge tube. This is the original experimental setup of cathode discharge ray tube. The results of the experiment are, the cathode rays start from cathode to anode. These rays themselves are not visible, but their behavior can be observed with the help of fluorescent, which glow when hit by them. Here the fluorescent material is zinc sulfide. Yes, it will move from cathode to anode, and we know that cathode rays are completely invisible. They are not visible to our naked eye, but their behavior will be observed when it will hit to the fluorescent material, that is zinc sulfide, as a dark spot. That time we can tell it has moved. In the absence of electrical or magnetic field, these rays travel in a straight line. But in the presence of electrical and magnetic field, the behavior of cathode rays are similar to the expected from the negatively charged particle. When without the application of the magnetic field and the electrical field, it was moving in a straight line. That when they have applied the electrical and magnetic field, the behavior of negatively charged particles were deflected towards the positive end. By that he showed that cathode rays are negatively charged. It suggests that cathode ray consisting of negatively charged particles called electrons. The characteristic of cathode rays do not depend upon the material of electrodes and nature of gas present in the cathode ray tube. What he did means, he gave a characteristic nature and he told cathode ray do not depend on the nature of gas or electrode material. Whatever metal you can use, whatever gas if you use, the characteristic of cathode ray will be remains constant. These are the results of the experiment. Next is charge to mass ratio of electron. This was also proposed by the J.J. Thomson in 1897. What he did means measured the ratio of electrical charge to the mass of electron by using cathode ray tube. What means that cathode ray tube, discharge cathode ray tube was partially evacuated, but this discharge tube was completely evacuated. Okay, this is electrons propagating way, and how they have placed means here electrical field is also there, magnetic field is also there, but how they have set up, there is also a one rule. They have set up in such a way the electrons or the particles propagation are perpendicular to the electrical field and magnetic field. But before that, magnetic field and electrical field were perpendicular to each other. For both, this particle propagation was perpendicular. Okay. And what they did, the particles start moving, and when the only electrical current was applied, that time it showed a deflection towards the A point, that point A. When only magnetic field is applied, the propagation was deflected towards the point C. When both the electrical field and the magnetic field has been balanced and they have produced in the ray tube, That time the propagation was in a straight line at the point B. It was hitting towards the fluorescent screen. This was he showed. Electrons are produced by heating a tungsten filament electrically. Here whatever the electrons are propagating, that was produced by heating in a tungsten filament. Electrons projected at constant speed across a magnetic field in the direction perpendicular to the electric field. That's what I told. It was perpendicular to each other, and this is the experimental observation what I told. And the factors which are affecting the electrons movement is magnitude of negatively charged on particle and mass of particle and magnetic and electrical field strength. If the greater is the magnitude of negatively charged, greater is the reflection. When mass of particle is light, then greater will be the deflection. And if the magnetic and electrical field strength is more, then deflection of electrons will also be more. Okay, these are the three factors which affects the electrons movement in the discharge ray tube. This is about the charge ratio of electron. Next, the charge on electron. By carrying out accurate measurements of the amount of deflections in the presence of electrical and magnetic field, J.J. Thomson was able to determine the value of E to M of an electron, that is 1.76 into 10 to the power of 11 coulombs per kg. J.J. Thomson, by showing all the experiments on an accurate level or accurate measurements, he told charge on mass, that is 1.76 into 10 to the power of 11 coulombs per kg. And what was the charge on the electron? Charge on an electron was determined by R.A. Millikan by using an oil droplet experiment. In the next slide we will see what is oil droplet experiment, but the charge on the electron was determined by the R.A. Millikan. What he determined means mass of electron will be electron value and charge to mass ratio. Okay, what is the electron value? 1.6022 into 10 to the power of minus 19 coulombs by charge to mass 1.758820 into 10 to the power of 11 coulombs per kg. Overall, if you do the calculations, you will get 9.1094 into 10 to the power of minus 31 kg. It is the mass of electron. Okay, and this is the Millikan's oil droplet experiment. In this experiment, what he did means, oil droplets in the form of mist produced by the atomizer were allowed to enter through a tiny hole in the upper plate of electrical condenser. This is the overall electrical condenser. This is atomizer where the oil droplets was produced in the form of mist. Here it is a hole in the upper plate of the condenser. Okay. And the downward motion of these droplets was viewed through the telescope equipped with the micrometer eyepiece. And the oil droplet starts moving downward in the condenser. It was completely absorbed by the telescope here. Okay. By measuring the rate of fall of these droplets, Millikan was able to measure the mass of oil droplets. It starts moving, right? That time, when it will move downwards, the velocity, by seeing this or speed, he was able to identify its mass of the oil droplet. The air inside the chamber was ionized by passing a beam of X-rays through it. The electrical charge on these oil droplets was acquired by collision with gaseous ions. What he told means, here already air particles was present in the air condenser, that was completely diminished by the X-ray whichever they have provided in between. Okay, that gaseous ions was completely out and only the oil droplets were present. The fall of these charged oil droplets can be retarded, accelerated or made stationary depending upon the charge on the droplets and polarity and strength of the voltage applied to the plate. Here, the fall of charged oil droplet can be retarded in the condenser due to the depending upon the polarity and strength of the voltage applied in the plate. By carefully measuring the effects of electrical field strength on the motion of oil droplets, Millikan concluded that magnitude of electrical charge, that is Q on the droplets, is always an integral multiple of the electrical charge, that is Q equal to NE, where N is 1, 2, 3 or infinity. Okay, he told that based on depending upon the charge on the droplet and the polarity strength, the voltage will be applied. And overall, carefully getting all the effects of electrical field, he told oil droplet or the magnitude of oil droplet will be integral multiple of the electrical charge. By this, he showed the charge on an electron. Next is discovery of protons. We know that atom was a neutral particle, and also when there is a presence of negatively charged, it is also a presence of positively charged also. That's why Goldstein discovered the protons by the discharge tube. Same experimental setup what we have seen in the cathode ray discharge tube, but the difference is there anode was perforated, but here cathode is perforated. That rays was moving from cathode to anode, but here rays are moving from anode to cathode. At the same time, when the electrical charge, when the electrons are moving from the cathode to anode, that's the same time that anode rays will also start moving from anode to cathode. That's why we'll call it as anode rays. Okay, this is the experimental observations. We'll see here. Goldstein experimentally proved that existence of positively charged in matter. Yes, anode rays are also known as canal rays. Okay, same to that cathode ray. Little bit difference is there which I have already mentioned. The characteristics of these positively charged particles are, the positively charged particles depends upon the nature of gas present in the cathode ray tube. We have studied that cathode ray tube, whichever in the cathode ray discharge tube, there is also presence of gas, but that electrons are not dependent on the nature of gas or electrodes. But here the positively charged particles are completely dependent on the nature of gas. Why means these are simply positively charged gaseous ions. Okay, why we are calling as simply charged gaseous ions? Because one time the particles are moving inside the discharge tube. After giving the gas, the ionization will take place. One side the cathode rays will take the electrons and positrons are taking up. That's why first time the cathodes will absorb, second time positively charged particles will be absorbed. So, to identify or to observe the positively charged particles, nature of gas is very much important. That's why we'll call it as simply the positively charged gaseous ions are present. The charge to mass ratio of the particles depends on the gas from which these originate. Okay. Some of the positively charged particles carry a multiple of the fundamental unit of electrical charge. The behavior of these particles in the magnetic or electrical field is opposite to that observed for electron or cathode rays. What they are telling means the behavior of the anode rays are completely different to the behavior of the cathode rays when it is subjected to the electrical and magnetic field, because cathode rays are moving towards the positive end, but this anode rays will be deflected towards the negative end. That's why it is completely different to the cathode rays. These are the observations and characteristics of the positively charged particles. And after discovering of electrons and protons, Rutherford told that or predicted that atom is a neutral atom, means already there is a discovered of proton, discovering of electron, but there is a presence of neutrally charged particles also. So he predicted. Later, based on that prediction, Chadwick in 1932 bombarded the element beryllium with alpha particles and noticed the emission of a radiation having the following characteristics. What are the following characteristics of a radiation? Means the radiation was highly penetrating. The radiation was unaffected by magnetic and electric fields, which show that is electrically neutral. Okay, these are the characteristics of radiation. What that Chadwick did means, from the source of alpha particles, he projected or he directed the alpha particles towards the beryllium plate. That alpha particles hit the beryllium plate and it was coming out as a source. But it was a strange, why means completely it was highly penetrating, okay, and it came as a beam of neutrons. It is highly penetrating power and it was completely unaffected by electrical or magnetic field. So it showed that it is completely neutral in nature. It is found to have approximately the same mass as the proton. What Rutherford also predicted means, only having the mass of proton could not accommodate the mass of an atom. Based on that mass prediction, he told there is a presence of neutron. That prediction was showed correct or successfully in this reaction. After this experiment, beryllium hit by alpha or heavy source, it showed the carbon and the neutron. This is the neutron. And it was approximately showed that the mass of neutron is also present in the atom. A neutron is usually represented as N and its charge is 0 because it's completely neutral in nature. After discovering the proton, neutron and electron, the properties of fundamental particles are shown like this. Name electron, symbol small e, all the fundamental particles you should write in small letters, and it is nature is negatively charged. Absolute charge is 1.6022 into 10 to the power of minus 19, relative charge minus 1, mass 9.10939 into 10 to the power of minus 31, and mass in unified is 0.0054, approximately 0. And proton P positively charged. See here, both the electron and proton are same having the charge but with the opposite signs. Plus 1, 1.67262 into 10 to the power of minus 27 and 1.00721 of mass, and here 1. Neutron small n completely neutral and absolute charge is 0, relative charge is also 0 and mass 1.67493 into 10 to the power of minus 27. Here Rutherford prediction, the mass of proton not only accommodate the mass of atom, it involves something that is nothing other than neutron, which its mass is 1.67493 into 10 to the power of minus 27. By these two, it will concise the mass of atom. See here, if it is nucleus, it's a orbital means in the nucleus positive and neutral part is present. Here the electrons are present, right? This mass of atom should accommodate. That's why they have showed here. And the mass is 1.00867. The relative is approximately is 1 mass. In the next session, you will study about the atomic models, Thomson model of atom, Rutherford model of atom. I hope you have understood what I have taught today. So, we'll meet in the next session. Keep on watching for the further videos. Thank you.